normal.
RCP chamber pressure looks good.
Doubling up. Roger roll, Atlantis.
Water towers can fly! Yes!
Tango Delta nominal.
Fighting outside speed off. Bring in speed off. Off.
Yikes. You bet. Concur. We don't need any more of these.
What's up, everybody? In there, out there, all around the world. Welcome to NASASpaceflight Live for this week. I'm Jack Beyer. I'm a photographer, host, live streamer, videographer, whatever you want to call me. And I'm joined today by Assistant Managing Editor of NASASpaceflight, Chris Gebhardt. What's up, Chris?
Hey, everything's going great. Doing well myself. How about you, Jack?
No complaints. It's another Saturday. And of course, you might notice a new face on the stream, a different face. You should know who he is, but in case you don't, it's Joe Barnard of, or should I say Bo Jarnard of BPS.space. What's up, Joe?
Howdy, Jack. Thanks for having me on.
It's a pleasure. Actually, I'm really excited for this interview. We've had some cool guests, and this is continuing the trend, so can't go wrong there. So if you guys don't know, Joe is, the founder of BPS.space. Is that the right thing to call you?
Sure, yeah. It's a rocketry project / business. We launch a bunch of rockets and kind of just do things that seem cool. Wish I had a better way to describe it. But yeah, it's a rocketry project. It's a YouTube channel. And then I just lose my mind on Twitter every once in a while. So that's about it.
That's something I want to talk about maybe towards the end of our BPS.space conversation. I can't even express it. I love your Twitter. It's so, it's just like, I actually have you on notifications. Yeah, I have you on notifications, and I know that I'm going to get a little snippet of something funny every now and then, and I appreciate that. But I digress. Rockets first. So BPS.space, you started it years ago, right? As sort of your endeavor to launch and land a model rocket vertically. Is that correct?
That is, yeah. I started it as a way to try and get a job at SpaceX. I think most people here have heard the spiel 1,000 times, so I'll do it quickly. I started this project as a way to get a job at specifically SpaceX, but really I just wanted to work in aerospace because I had graduated college. I knew that I had a degree in the field that I didn't really want to work in anymore. And so I figured, okay, instead of going back to school, I'll start this project. So I didn't know anything. I learned trial by fire for most of these things. So have sent a lot of rockets directly into the ground. Some of them faster than others. And yeah, it's been like, I think at this point we're coming up on 5 years, which is insane. But I have learned a lot. I feel like, it's been not as successful in the original goal of trying to get a job at SpaceX, but the goal has also changed because now it turns out I really just like doing this. It's able to provide an income, and I have a ton of fun doing it. So we're just kind of seeing how far this can go, and that's it. Yeah.
That's awesome. I mean, I could definitely identify with that. I went to film school so I could make cartoons, and then I moved to LA and was like, oh, there's all these things I can take photos and videos of. I kind of just enjoy doing this, and it's sort of led here, crazily enough, and just pull the thread, I suppose. So I guess we can get into BPS.space a little bit more. You build and sell flight computers, right? And Chris, feel free obviously to jump. I'm just babbling here, so feel free to jump in if you want to at any point.
I will, definitely.
So BPS, you actually sell a little flight computer that goes in the model rocket that allows you to make the rocket do certain things, right?
Exactly, yeah. The flight computer controls the direction of the thrust of the rocket, which is called thrust vector control. You control the vector of the thrust. And so it's sort of a little kit that I sell. The sales aren't active right now. We're sort of changing a few things around, but essentially, you put one of these things in an existing rocket, and it's able to stabilize itself without using fins. And one of the benefits of that is that you don't have to go really fast to remain aerodynamically stable. You launch like a Falcon 9 or an Atlas V, where this thing is, you can rise really slowly off the launch pad. And there are some physics things that don't quite scale there. So you still have to go a little bit fast. But the idea is to sort of increase the realism and complexity in these models. And I really like doing it. I think it's it's an interesting addition to an existing hobby.
Yeah,
So
go ahead.
yeah, one thing that fascinates me about this is what sort of regulatory processes do you have to like abide by? Because I mean, I don't know. I would imagine that I mean, this is slightly different than just, put in the little motor that you get at the, at the hardware store or the hobby
Mhm.
store and, shoot it up 100 feet.
Yeah, I wish I had a better answer for you, but I'll sort of outline, where I see it right now. There's a tremendous amount of gray area, and I think that's sort of done intentionally. But the general consensus is that stability is okay, which means that so long as the rocket is trying to point up, or it's not trying to point at like a really specific location, so like targeting, right? That's right. Like just to follow like the logic through the problem, the immediate problem that a lot of people think of when they think of this is like, okay, well, is it a missile? Um, and the answer is no. But yeah, so if you're just trying to remain pointed up with a relatively slow control system, and if you're using like 3D printed parts, you're not going crazy fast or have tons of forces or anything like that. So that's one aspect of it. The other one is in the technical sense, like there's just a decent amount of gray area, but I will tell you where some of the gray area is not. There are actually no like domestic regulations against it. Different countries have different rules about model rockets, but in the U.S., we're actually very open in terms of the amount of rocketry that we can do and like the amount of ammonium perchlorate that you can buy. And yeah, I think I've talked to a number of different like legal
We're
firms. They will give
we're
you
all
30-minute
on
free
watch lists now.
consultation.
Thank you for that.
Yeah,
Yeah, yeah. Well, that was my
yeah,
next question. Yeah.
yeah. So I've talked to a couple of different lawyers. They're all really kind. They will give you like 30-minute free consultations and stuff like that. But then actually, working with these people on a few different things, it seems like it's mostly fine. And it's one of those things where these regulations, a lot of the ones that like a lot of the ones that would sort of involve this are written in the 90s before like MEMS technology had really taken off. MEMS is electromechanical system, which basically deals with like all of your cell phone grade sensors that allow this thing to do everything it can. And so I'll try to round out the point, but basically some of the regulations are a little outdated, and it's more about looking at the intent of the regulation rather than the exact words, if that makes sense. But it is fine to fly these things, especially by the National Association of Rocketry and Tripoli, which are the two major rocketry associations in the US. I've spoken with both of them, and they're cool with it. I mean, people fly the kit at club launches. And I am not a lawyer, I'm not a legal expert, but from everything that I've seen and doing this for the last 5 years, it's totally above board.
It's just so cool to me that I'm sure a huge percentage of our viewers have built a model rocket like out of the kit from a box from a hobby store, but this is just such another level above that. That it's a rocket with a computer system in it. It's got its own reaction wheels. Like it's got
Yeah,
this one can attempt to land. It's just
the landing was crazy. Yeah,
No.
it's just crazy. And I mean, we're putting computers in these things now, and I don't know. I find it so cool. So if you guys aren't subscribed to BPS.space, definitely make sure you go over there and hit the subscribe button and watch some of his videos. Speaking of your videos, your intro video is absolutely, I mean, I love it. And really your videos in general, just as someone who shoots video, it's like there's like macro shots of like a little chip going on a board and then the solder melting. Like, I mean, that's got to take a lot of effort, right? To sort, I mean, you have to do it, but you also have to do it for camera. You have to get the camera right. You have to get the lighting right. Like, it's a huge amount of effort that goes into not only these rockets but also the channel, right?
yeah, and it's one of those things where like if you do it right, it makes it look very easy. And Jack, you know it because you've done it before. When you like film this stuff to put on YouTube, if I were working without a camera, if I were not trying to publish these videos, I'd be going at least twice as fast, because there's all of it. Like you can see it in the shots here now. But there's all these instances where I'm like, okay, cool, got to get the tripod set up. Let's frame the shot. Let's get the lighting correct. Oh, shoot, my ISO's too high. Like whatever. And then you're thinking about like frame rate, and then after the fact, you've got to like go cut through all of this footage, and a lot of the clips are way too long because you're the only one filming, and it looks very easy and it looks very cool in the shots, and it ends up taking a decent amount of work. But I don't know, like after the fact, it looks great. So
even just the editing aspect of it, like you have to really kill your darlings when you're editing, and it's like this super cool shot of the CNC thing getting milled. Like I want to let it play out, but I've only got like 30 seconds to let it go. Like the choices of shot, like it just, anyways, I could gush. It's like an Apple commercial, but for rocket videos, and that's like one of those things where I saw somebody create something, and I was like, oh, I have to be better. It's really good.
What we're seeing on the screen now with all of when you see me wearing the purple gloves, those are the hardest ones to get because you've got to the gloves are covered in epoxy, right? And like you really don't want that on a nice camera. So like every time I've got a new shot, I'm taking off the gloves. I'm like, cannot be good for the environment, but I'm like taking off a pair of gloves, reframe the shot, hit record, put on a new pair, and then like do what I need to do.
I mean, it's. I mean, I just want to say, like, from what Jack was saying too. I mean, like, it's so impressive from just a film perspective because you're playing the role of everyone on like a Hollywood film crew, and you're producing things that are just, I mean, amazing quality, man. I mean, like Jack wanted to gush. I just wanted to say that, like, I mean, because yeah, I mean, if you know how hard it is to just do one element of a video shoot and to know that you're doing them all as one person, it's incredible.
It's a lot, and yeah. Sorry, go ahead.
No. I mean, I'm just a huge fan of it, and it's got to be, as someone who doesn't launch model rockets or build model rockets, when I watch your channel, I want to do it. Like it's like a friend sitting on my shoulder, just yelling at me, like, "Build model rockets! They're really cool." So like. A good aspect of this, and part of the reason I gush is because this is a really cool thing that other people might watch your channel and think, oh, I could build a rocket, or I should give that a try, or something along those lines. Is that part of, so you've been working this summer, right, on a thing you call Hot Nozzle Summer, right?
Oh yeah. So I can't take almost any credit for this either. It sort of spun out of like amateur rocketry Twitter, which is this group of like informal group of people that just all really like amateur rockets. Yeah, there's a nice photo of so that's Scott Manley, Everyday Astronaut Tim Dodd, and then Zyla Foxland, who's another great YouTuber. But yeah, we all of the credit really goes to the people who organized it. So Jenna Furch and Matt Patrick. But I don't know exactly how it happened. At some point, someone tweeted the hashtag Hot Nozzle Summer, which is a play on Hot Girl Summer or Hot Boy Summer, which is great. Like, go ahead and have yourself a Hot Girl Summer. But like which is also a variation on Hot Girl Energy. There's a lot of potential to really be hot, I think, is the main point. But Hot Nozzle Summer was a jokey hashtag, and then someone was like, "What if we all met up though? Like, what if we all met up and flew some rockets?" And so the people who organized this event worked super hard, and they put together this meetup. Basically, it's at the Friends of Amateur Rocketry site in Mojave. It's actually in Randsburg, California, but like, who cares? It's cooler to say Mojave. And so it's at this site. A lot of people got their what's called an L1 certification, which is basically like dipping your toes into flying high-powered model rockets. And so you learn a lot along the way. You build a rocket, you send it up to like a few thousand feet, and then it comes back. And it's a great way to like get people into rocketry. It's not too hard to do on your own. And the event was like a total success. It was kind of amazing. Honestly, the thing that I was amazed by most is it just happened. So like last weekend, that's when it happened. And that's like the end of July in like the biggest heat of the summer, like 110 degrees.
In the
I went into it expecting like there's no way that 6 people don't come away like in an ambulance, like from heat stroke. And we were so on top of it. It was awesome. No one got hurt. It was great. It's a weird thing to like highlight about the event, but that was my main concern, was that it's the desert in the middle of summer, and it was just a total success.
Now, the reason it wasn't a problem is because you took it seriously and didn't just go, well, it'll
Right.
be fine, right? And you kept
Yep.
hydrated. That's great.
And it looks
So-
like, sorry, go ahead.
Oh no, what were you saying? Looks like what?
Oh yeah, sometimes you can look at those things from the outside and be like, well, I don't, like I'm not sure how much planning is going into this, and like I cannot emphasize enough how much planning went into this in terms of desert safety. When people went out to walk to find their rockets, we had a whole protocol for keeping people safe out there, and just a lot of forethought went into it, and I think that's really what made it such a success.
That's awesome.
About how many people were there? Because there were some photos. A lot of the photos I saw, it looked like a small group, but then there were like some group shots where it looked like I'm horrible at guessing, so I won't even give a number.
Me too. I think there was some number close to like 150 people. We had, some hard caps on the amount of people that we could have there, and I didn't count, but I think it was around 150. And the event was 2 days, so it was Saturday and Sunday. Most people, if not everyone, flew Saturday, and then Sunday was sort of an overflow day for people who showed up and weren't quite ready, or like weren't ready to go. This one's great, by the way. The one that's on the screen. This is a Denim Rocket. It's a jocket, if you will, a jeans rocket. But yeah.
Please tell me the person who launched it was wearing jorts.
Oh yeah, no jorts.
Okay.
Also a a jeans hat.
That's amazing.
Yeah.
That kind of goes into a question I have for later about, can you just build anything that you want? You can just build any kind of rocket you want as long as it's safe, right? Like if you wanted to build a super wide rocket that, made no sense at all, but flew and was safe, you could.
Yeah, so the way that we did this is that, a lot of people showed up, and they showed up with their first rocket that they built. And so there are going to be some people who show up with designs that are like a little on the sketchy side. And so we had a whole team of people. We called them RSOs, like range safety officers. But really, what it was is we had people who were validating the safety of designs before we would put them on a flight card and get them like in a launch queue. So you'd show up with your rocket. You'd demonstrate like, okay, cool. Here's how I built it. Let's look at the simulations of how it should fly. Let's look at like check the integrity of the fins on there. Make sure they're not coming off. Make sure your motor's put together correctly, all that type of stuff. And so we had very few people with abnormal flights, and a lot of it was really just like a manufacturing error in the motor, or we didn't place an igniter right. And so again, I don't know why I keep playing up the safety thing, but it was like a pretty resounding success there. So you can fly anything you want, so long as you can prove that it is safe to fly.
Yeah, no, you're not playing up safety at all. It's important to be safe with things that hurtle through the air at high speed.
Yeah, right. You don't want to get hit,
A little bit. But
so, go ahead, Chris.
Yeah, so it was a meetup. Like, was there any was there any objective, or was it really? It sounds like it was just like a bunch of people who are all interested in the same thing, just kind of coming together to support everyone and have fun and do it in the safest way possible, which is awesome. I almost hate to ask, was there any other point to it? Because that's a great point.
I mean, I think
in of itself.
I think there are a couple of different objectives with the event. A big one was sort of making sure that like anyone felt like if they wanted to, they could join this event and show up. So just making sure that like it doesn't matter what your background is, it doesn't matter like who you are. If you want to build a rocket and fly this thing, we will make sure it's safe. But like show up with a rocket and let's fly it. And so I think a big part of the event was just emphasizing that like you don't have to like have previous experience with rocketry. We will cover those bases for you. Like if you want to meet a bunch of people who also like rockets, and if you want to fly some stuff in the desert, I think the social aspect was a big point too, right? Like we're coming I mean, it's hard to define when this is, but like we're coming out of a very tough year where we couldn't see a lot of people. And so the social aspect of like, all right, let's meet everyone now. So let's get an event together where we can all meet a bunch of like-minded people. That was a big part of it too, I think.
Yeah, there had to have been a little bit of culture shock from being like, oh my God, there's so many people. At least that's how it's been for me, for sure.
Mm-hmm. Yeah.
So I love the aspect of it that was just like everybody encouraging everybody. Like there's seemingly, like from the outside perspective, I just see a lot of people encouraging a lot of other people, and that's really, really cool. So you recently, Joe, tried to okay, let me start over. You have been working on getting your L2 certification, right?
Oh, yeah. So I've been working on getting my L3. I have my L2.
L3,
There are
sorry.
basically like 3 levels that you can get. You get your level 1, your level 2, and your level 3. I've been working on getting the L3. That is by far the hardest one. You have to fly a pretty big rocket and then have it go well, and then have a bunch of other things lined up that work. And you can see it on the screen here. So I flew this in April, and it's quite the story of like how much this didn't work. But basically, the gist of it is I built this rocket to get the L3 certification from the NAR or from Tripoli, from one of these major organizations. And basically, like, you fly the rocket, you prove that it's good, and you work with a bunch of mentors along the way who are like, yep, you're doing a good job. And we just ran into problem after problem. One of the things that I didn't do one of the things that I would do differently if I went for the L3 certification again is I would build a much smaller rocket. So there are like, limits of, there's a lower threshold where you have to use a motor that is X big. You have to build a rocket that, can go this high or something like that. There's actually no height restriction, but I looked at those and I was like, that's ridiculous. I'm Joe Barnard. I'll do what I want. And so I built like, it's what's called a minimum diameter rocket, which means that more than half of this thing by weight is just propellant, which is like, that's common in an orbital launch vehicle, but it's not common in an amateur rocket. So more than half of this thing is propellant. I tried to send it to 10 kilometers. You could certainly go less. It went Mach 1.7. And that's just a lot to bite off if you haven't built one of these things before. And so we had failures on the telemetry system. We had like 2 different bands of telemetry from 2 isolated computers, and both of them dropped out after about 4 kilometers up. We had a failure of the recovery system. So what you see right on the screen now, like, we should be looking at a parachute that is fully inflated under there, and instead it is like ripped to shreds because we deployed the parachute when the vehicle was going too fast, and so it shredded the parachute. And then you can see all these tangled recovery lines that are like just flapping about in the wind. So we had a recovery failure. We also launched delayed by a week because the first day that I showed up to do this thing, I was just not ready at all because I hadn't done something like it before. And I think the lesson to take away from this is like, yeah, you can build whatever you want, but also it's not bad to just to not way overshoot things sometimes.
You have to follow, you have to pull the thread that you're interested in. If you're
Yeah.
not interested in it, you're not going to necessarily put your all into it. So you did what you did what you were called to do. I mean,
Yeah.
I'm sure it's not fun to watch the thing you spent so much time working on flailing around in the air. But
That's
as a
fun now.
viewer,
It hurts a lot less now.
Good.
Yeah.
As a viewer, I don't know. Do you know the Chemical Safety Board? It's like the United States Chemical Safety Board videos.
Yeah. Oh, those are great. NTSB does those too, right?
Yes.
Yeah.
I consume those like a kid eating jelly beans. I don't know what it is about them. I guess there's something wrong with my head, or like engineering disaster podcasts. Like, shout out to Well, There's Your Problem. They're so good.
Uh-huh.
You basically made, with all of your footage, like the footage of you at the whiteboard doing the line diagram for the shoots, like you have every step of the way like an engineering disaster masterpiece, but it's like nobody gets hurt. You learn lessons and you pick up and move on to the next thing at the end, and that's like, it's just good, clean fun. Let me put it that way. It's really good content, and I'm sorry it didn't go as you planned, but it's really good content.
Yeah. Well, thank you, Jack. I mean, it's one of those things where like it is actually legitimately we were very safe about building this thing, even though it failed. We're you can see in the top right corner like we're all in a bunker that will survive getting hit by a rocket. It's you know it did fail, but it was safe the whole way. And then the other aspect is like, well, I figure I learned a lot from this. Whatever I can put back out into the world of like, hey, if you're doing one of these things, maybe do it a little differently. If we don't learn from it, what's the point,
Yeah, absolutely. So, so that happened. It did not hit the Earth at an acceptable speed, although it did
Nope.
hit the Earth at a righteous speed.
I'll tell you, we did recover it. It came back only by like sheer dumb luck. So I mentioned earlier that the antennas, it's honestly hard to figure out exactly what happened, but we had a ton of RF loss, basically so that once we passed about 4 kilometers up, like everything blacked out. We didn't have any idea what was going on with the rocket, and that's a really scary thing when the rocket is like 50 pounds loaded and is essentially like an unguided missile.
And is going nearly Mach 2.
Yep. Yeah.
Yeah.
It doesn't make you feel great. And so, and and it's also something that like I poured hundreds of hours into. And so, as it was coming down, it's flipping around, it's doing all of these things, and we got about 4 packets of telemetry, like 4 out of, we should be getting 10,000 over the course of the whole flight. We just got 4 on the way down at one moment where it flipped around, the polar patterns of the antennas like aligned correctly. We got a little bit of telemetry with some GPS coordinates as it was like 3 kilometers in the air. And so we used those to like try and plot out, okay, cool, with the current wind speed, how far would we drift if the main parachute came out? How far would we drift otherwise? And you're just walking across like this huge, like dry lake bed in the desert trying to find this thing. And we eventually did. It took like 4 hours of searching, and both the computers were dead on impact, so we weren't broadcasting anything else. And we got it back. Yes, it's the shot.
Yeah.
On the one
That's
hand,
how we
it's
found
great
it.
because you're not leaving anything out in the desert, which is always a good thing to do. Leave it better than you found it. But it's also it's like an Apollo 13 style, like we have to find the thing so we can get the data, and it's like, how are we going to find it? And we have 4 packets, and it's just I'm sorry, it was probably hell at the time, but it was absolutely insanely compelling content.
I cannot possibly describe to you the like insane joy of seeing that thing and just screaming. Like seeing it for the first time, being like, oh my gosh, we are gonna get it back, even if it's totally crunched, right?
Yeah, I mean, it is crazy that you can like go sift through the remains and pull out little computer chips and be like, all right, we got the memory chip from the computer. It's a little tiny thing the size of your pinky nail, but we can pull data off of it by putting it on another computer that's not busted to pieces. Like, you're blowing my mind, and I love it. Chris, did you have something?
Well, this is a great picture for the point that I wanted to make. No, because Joe, one thing that truly like drew me to your stuff at the beginning was that you don't hide the disappointment. You don't hide the elation. If something doesn't go wrong, you're not afraid to post like something of you crying, because that's a lot of work, right? And when something goes right, I mean, when we sit there and we see you bouncing in your chair when you get the but I mean, like that's I think like what you do very, very well, and I think what draws me to your videos as well, aside from the editing, is you're not afraid to shy away from the human element of this, which I feel like a lot of people do. Like, oh, bummer, it failed, but like you're like, no, that sucks, and let me tell you why. But yeah, and I really do appreciate that about your videos, and that you don't wish to hide that element of it.
Thanks, Chris. Yeah, I just it would help, like if I were outside of me, if I weren't me, I feel like that is the stuff that I would also want to see, which is like, nope, this is the like pretty unfiltered real experience of like, I poured, and even aside from like the financials of buying a motor this expensive, but like I poured so much into this rocket and then I destroyed it. Like that's, it would make me feel better to see someone else go through that and be like, all right, cool. Like if that happened to me, I at least know I'm not alone, right?
Yeah, and it's valuable. It's valuable because we live. I don't want to sound too preachy, but like we live in a world where social media is like perfect and polished, and I'm guilty of that. I only post things that I think are really good. That I'm like, oh yeah, this is. No, go
Can I
ahead.
interrupt you? Yeah,
Yeah,
so
please.
this photo on the screen now, this is great. I think this is around the time that, so this is like the day before launch. There's a video that's going to come out pretty soon about it. This is the day before launch. I am on no sleep. I have had a banana the entire day, like as a meal.
Oh
Uh,
God.
and it's like 4 p.m. And at this point, we should be back up in the Mojave Desert as opposed to like at the Airbnb in Los Angeles somewhere. We should be back up in the desert, like prepping for flight, because it's the day before launch. And as we're running through the pre-flight checklist, I plug in the flight computer to test the like live video feed on the rocket. I plug it in, and a bunch of smoke comes out of the computer, and there's this huge pop, and then there's this like 30-second silence where no one says anything. And so this photo is of
No.
like about a minute and a half after that happens, where we're all in the Airbnb like, this is not good.
Wow.
We are in really big trouble here.
Wow.
Oh my
You made the
gosh.
magic smoke
Yeah.
come out of it. That's bad.
Yeah, no, you can't put the magic smoke back in. Yeah.
Oh my God. Wow. What I mean, but that stuff's appreciated because we all have highs and we all have lows, and I don't know. It's fun to ride
Mhm.
along with you on Twitter. So thanks for not just
That was
doing like a
very
perfect
low. Yeah.
polished social media presence. It's way better what you're doing. So what
Thanks.
is next for BPS space? What next?
Okay. Yeah. So I gotta finish the rocket landing stuff. I have had one flight of the rocket that tries to land, and it was really close. And closing that loop, like getting it all the way to the point where it can land, is pretty trivial. We need to do two things. We need to increase the accuracy of the guidance system. So when we touched down last time, we had a little bit of slide, and so we tipped over. And we also have to get rid of the bounce that's in the legs. Everyone's like, try landing on concrete, or try, putting some spikes on the legs. And there's all of these things. Yeah, you'll see it on the screen now. It bounces and then tips over. So like, if the success criteria is that you get the rocket back and it's undamaged, then yes, it succeeded. But it looks way better to land and then not tip over. So we have to close that last little bit.
Yeah, it's
And then I
vertical
can be
landing,
like,
vertical takeoff, vertical landing, right? Not vertical takeoff, vertical then sideways landing. It's way cooler to be vertical both times.
yeah, you want to be vertical both times. So I have to finish that project. A lot of the leg modifications are pretty much done. I need a little bit more code work to do in like the flight software, and then that'll hopefully be done by this fall. And then I want to do two other rockets. I want to do Lumineer V2, which is like the huge rocket. I want to rebuild that and do about the same flight profile, but get it right this time, where we go to 10
Awesome.
kilometers and back. And then I
Nice.
also want to get my level 3 certification finally, and I'm going to do that on the smallest, simplest rocket I can, learning from the lessons that I learned this spring.
So you're still going to do a Lumineer follow-up, but you're not going to use that for your L3.
That's correct. Yep. And I think the Lumineer follow-up, we may pour a custom motor for it too. Like we might move away from commercial motors for that, because the other thing that is the big thing on the horizon right now is a space shot, a rocket that goes all the way up to 100 kilometers. And we're not going to have the 80 versus 100 kilometer conversation here. We're just going to say it's 100, and like that clears all of the bars. So yeah, so I want to do one of those. I think it could probably happen in a year and a half, maybe 2 years. It's a very aggressive goal to try and get something to space. And only a couple of amateur people have done it. And then literally only one college or university has been able to do it. A lot of people have tried, but it requires spending a lot of power in the right direction at the right time. And I think I can do it with enough time and enough forethought. So that's coming up sometime.
All of that sounds really amazing, and I'm super, super looking forward to watching the developments of all of the above. I mean, Space Shot, that's like just like wow. Super,
it just
super
is like
cool.
So cool. Like I just love the idea of like being able to send something to space. It doesn't have to stay up there. I can't get to orbit on my own. Like that's not a realistic goal. You need a team of people with that. But I think with 4 or 5 people helping me out, volunteering some time, if we get a little scrappy about it and cut some corners that we can cut safely, I think it can be done. And we'll see. I mean, maybe it can't, and then we'll learn a lot along the way. It'll still make some great videos, but we're gonna give it a shot.
Awesome. Well, if you
Yeah.
guys want to support what Joe does, I know you've got a Patreon for BPS.space, right?
Mm-hmm.
So
Yep. There are a
be
couple
sure
of
to go ahead.
there are a couple of ways to support it. Yeah. Honestly, the most helpful thing is just to share it with other people and say like, hey, this is a cool project, and that's the most helpful way to do it. But yep, if you feel cool doing it, the Patreon is a great way to support it as well. We have like a whole access to a Discord thing. There's also like a little bit of merch that we sell. It's like shirts and hats and stuff like that. And then again, the best way is just, I don't know, follow along with the videos and try to tolerate me on Twitter.
Yeah, well, definitely. I mean, like I said, I'm looking forward to get you getting your L3. I'm looking forward to Lumineer V2. Is that what you called it?
Yeah, we'll see
V2B?
what the name is. It might be different, but I'm calling it
Okay.
Lumineer V2 at this point.
And at some point in the future, the space shot. That all sounds super awesome. Well,
Yeah.
oh yeah, really quickly. I know this is probably a little bit of a question you get a lot, but like, do you have any like words of advice for someone that wants to start doing model
Mm.
rocketry,
Oh.
high-powered model rocketry? Like,
Yeah,
where do
just
you
start.
start, or like just start looking stuff up online and go for it, kind of thing?
Yeah, I think a lot of people fall into the analysis paralysis thing of like, well, I don't know where to start, so I won't start anything yet. Just start. Like there's some common sense stuff of like, you can't just start trying to make motors and things like that. Like that gets pretty dangerous pretty quickly. But there are lots of resources online for how to build a high-powered rocket. Lots of resources for how to build a low-power rocket. Pick up a kit. Just start. Find a local field. Make sure it's cool with your local regulation, but then start flying rockets. There's like tons of experimentation that you can do at the small scale. I mean, the landing rocket that I have is no more than a meter tall, and most of the components aren't that expensive, but there's a lot of information online, and my advice is just start wherever you can.
Super cool. All right, well, thanks.
Yeah.
I think it's about time we move on to Nauka. Am I even saying that right?
Nauka.
Nauka. Chris, do you want to tell us about what's going on with Nauka? This is a crazy story.
Well, I'll start by prefacing this that I haven't checked on Nauka in an hour and a half, so it might be outdated based on how quickly things develop with this. Oh boy, our troubled little Nauka module. Okay, well, it successfully launched on the 21st of July on a Proton rocket, which everyone was kind of like, well, that's probably the biggest hurdle, right? Just getting it into space after, because this thing began its life back in 1995, and it's actually based on 70s and 80s technology, going back to the old FGB modules of the Mir and Almaz space stations. And it was originally designed as a backup to the Zarya control module in case Zarya was lost in a launch accident. We then literally could not build the rest of the International Space Station without Zarya. So they had this thing called FGB2, and when Zarya made it to orbit successfully, they were like, well, surely we won't throw something new away. So they came up with this great idea to reconfigure it into a science lab. And I don't say that with any sense of irony. It was a really good idea to make this and convert it into a big science lab for the Russian side. So they finally got it launched on July 21st, 2021. Its original launch date was 2007. Not a misspeak, 2007. And they finally got it to orbit. It underwent a whole bunch of issues after the Proton successfully got it into its orbit. And they were able to overcome all of those communication issues up front, a big propulsion issue where the main tanks got accidentally pressurized higher than they needed to be for that engine, and they had to burn some of the smaller engines to relieve the pressure in those tanks before the bigger engines could be used. But then July 29th, Thursday, it triumphantly arrives at the International Space Station. There was a bit of issues as it was under approach. When it was about 10 kilometers out, it wasn't on the correct trajectory yet, and they had to fire the thrusters in retrograde in order to get it back into alignment. They actually had to reorient the International Space Station after all of the issues came up so that it could actually dock along the velocity vector instead of the radial vector because it didn't have enough propellant for that anymore. And I mention that because therein lies some of the issues. um, so it successfully docked. They got it onto the nadir port of Zvezda. And then about 3.5 hours later, after they had opened the hatch from Zvezda, but hadn't yet opened the hatch to Nauka, um, Nauka just decided, wait, am I not docked yet? And started firing thrusters.
Not good.
This is the nearest we can figure, is that it basically got to a point where it kind of forgot what it was doing and lost track of where it was, and basically began trying to dock again because it started trying to reorient the station back into a really off nominal attitude that it needed to be in for the velocity vector docking earlier in the day, but they had already put the ISS back into its original orientation. So Nauka starts firing its thrusters. The gyros on the international side of the station started trying to compensate for that, but they couldn't. The gyros just were no match for Nauka because it had the better lever arm based on where it was and where it was docked. And by the time they got 45 degrees out of orientation, they declared an emergency with the flight controllers and a loss of attitude control on the station, which did a couple of things. It switched primary control of the orientation from the gyroscopes over to the Zvezda service module thrusters. So Zvezda started firing, trying to correct this. But Zvezda didn't have a good lever arm either on this. So basically what you wound up with was for 45 minutes, Zvezda and Nauka were fighting each other. And while that didn't necessarily put the station in an immediate, like the modules themselves might come apart, it definitely appears that what NASA said about the crew not being in danger and the station not being in danger is not correct. And I say that because when all of the flight directors stand up and go, yeah, no, we were actually relieved to see the solar arrays and the radiators still attached after this was done, really hammers home, like, no, this was not what public affairs tried to make it out to be, of
Wow.
a little hiccup, because so many flight directors were like, yeah, no, not at all what happened. It also doesn't appear that what public affairs said of the ISS being at most 45 degrees out of orientation was correct. 45 degrees out of orientation was when the emergency was declared, and they switched over to trying to use the Zvezda service module's thrusters to correct it. The other part of this is it's a little unclear how they got the thrusters on Nauka to stop firing. There are Russian media reports, Anatoly and Katya are both saying that they were hearing from their sources that it literally just ran out of propellant. It didn't have a lot left when they docked because they only had one shot at docking given the issues. So after 45 minutes, it appears that it may have run out of propellant. There were also some conflicting reports on the day that the Russian mission controllers got it to stop firing. But the thought that it ran out of propellant doesn't really sit right with me, because on the following day, yesterday on Friday, they actually passivated the system and they dumped the remaining propellant outboard of it, and they did a lot of preparations on board the station, closing the hatches between all of the modules, making sure all 7 of the crew members were actually in harmony, so that if they all 7 needed to pile into the Dragon, they could do that to get out of the station if that passivation of Nauka's systems had gone wrong. But they passivated it. There's no threat of it happening now. So really what they're working on is the structural analysis loads, just to make sure they absolutely didn't miss anything with joints, with the solar alpha rotary, the huge gears that allowed the solar arrays to turn and spin and track the station. They're looking at all of that to just absolutely make sure that the station is fine before Starliner lifts off. Because one thing they said is with Nauka, a new module doing all of this stuff, the last thing they want to add to the ISS is yet another new vehicle for it to interact with. So that's sort of where we stand right now. But it looks like Nauka is there and, God willing, won't misbehave again.
It's a really Kerbal-esque situation. I know it's like there's
It
human
was.
lives involved, but I mean, I think if you've played Kerbal and you've docked something and you've had your setup incorrect, suddenly you're spinning wildly out of control. And I mean, imagine if the solar arrays or the radiators had shorn off, and then you suddenly have
You're
debris
done.
in your orbit. There's just so much horrible wrong that could have gone wrong.
Yeah. not an unfair statement to say that the ISS was in a lot of danger on Thursday.
Yeah, it's interesting that we're just getting sort of the sugar-coated. Everything was fine, but let's see. Let me take a look if we have any questions. Joe, I mean, any thoughts on
My
Nauka
thoughts
stocking?
are bad. Don't oh, what if we never did that again as a treat?
That'd be great.
Like that, yeah.
Yeah, well, and hopefully the Prishal docking node that's going up in November, it goes up on a modified Progress vehicle, and the Progress is the propulsion elements on the Progress side don't normally malfunction. So, in fact, it was Progress MS-17 on the station that they ended up using because it had the greater lever arm because it was docked to Roosevelt, and they ended up using it to get the station's orientation back under control after Nauka stopped having its fit.
Just, oh my gosh. And Dragon could have undocked while it was in an off nominal attitude if they had to do that. That's a possible thing.
That is correct. Yeah, we asked this question at the post event. I'll call it a post event press conference, and yeah, the NASA did confirm that Starliner, Dragon, and Soyuz can all be powered up very, very quickly and can undock under the rotational rates that the ISS was under during its loss of attitude control.
Like
so yeah, they could have gotten away. Say what, Joe?
It was like a half a degree per second, something like that.
Yeah, the max rate was half a degree per second, is what they said.
Okay.
Yeah.
Yeah. Which sounds like nothing, but for something that big, that is still a lot.
Yeah, because that was the interesting thing is there was all of that structural stress, especially on the trusses and the solar arrays, but the crew didn't actually know it was happening until mission control called up and alarms started going off that they were drifting out of alignment. They didn't feel it, which was fascinating.
I sort of would have expected that. You know, you see like a video on YouTube of the station doing a reboost or something, and you can see like, you know, you can tell when it's doing a reboost.
Yeah.
But that's, I guess, a little bit of a different situation in terms of amount and direction and concentration of thrust.
Yeah, exactly. Because we did get the question a few times about was the station ever in any danger of being deorbited from this, and the absolute answer to that was no. The thrusters on Nauka and Zvezda can't do that, and nor were the thrusters on Nauka in any relative position where you'd be firing retrograde to do something like that. The station's orbit was altered because anytime you fire a thruster, you alter the orbit a little bit, but it wasn't anything major.
Got it. Let's see.
I also just kind of wonder. I mean, like, I don't build any of this stuff. I build model rockets, so like, who knows? But I feel like it's surprising to me that it lasted so long without someone being able to send a command that is like, hey, turn off everything. Like go into safe mode, right? Like a lot of satellites have a safe mode. Like, it feels like that should be a command that you could send, or maybe I misunderstand the situation. But
no. We have a question to that effect here from Andy Skibba saying, why would the procedure not be to cut power to new modules that they're docking to prevent these incidents? I mean, yeah, it's like.
Yeah, so I won't speak to the specifics with Nauka because they haven't said it, and I don't want to misspeak. But there are trade-offs that you do. So if we look at Nauka to help us answer this question, right? A lot of people had the question about, well, why didn't they put on an antenna that allows it to talk to the tracking and data relay satellite network, right? I mean, it's going up to the space station. Surely there are satellites, Russian communication satellites, not even NASA's TDRS network that it could have communicated with. And basically, they had to draw a line between launch mass. It was almost already at the limit of what the Proton could lift to orbit, and they just had to make a call, right? So they didn't have the communication dishes on there, which meant they had to be over ground stations in Russia. So I use that as the example of trade-offs, because the other things you kind of want to do sometimes are build redundancies into your system, where killing the main power element to the module doesn't necessarily kill the power in your propulsion system. because you wouldn't want the main power system to fail when you're 5 meters from the International Space Station, and then what do we do? The vehicle can't get away, it can't abort, it can't do what it needs to do.
Yeah.
So it may have been a function of that. It may have been a weird function of some post docking things had already been shut down, but all the physical connections to the Zvezda module hadn't been made yet. So it's a great question, and I was thinking it too, Joe. And to the person who asked the question in our chat, I was wondering too. It might have been that. It might have been a malfunction within the system, and they were clearly trying to get it under control. It's not like they were just like, well, let's see what happens for 45 minutes. I mean, they were trying to send commands to shut it down, and it wasn't working. And I think that's a lot of the reason that we very rightfully saw NASA, as soon as that happened, go, Starliner's going nowhere. We're not even chancing this. It's not even a question.
Sorry.
Which you got to feel bad for Boeing. It's not their fault, but better to wait. But yeah, it's a question I'm sure a lot of people had.
I'm stupid, but it's like space Jenga, right? Like you take one piece off, you add a piece on top, and then the whole tower becomes shifted.
It is totally like an armchair engineer thing to just be like, well, what? It's the same exact comment when you see a photo of InSight's solar panels on Mars. And they're like, why didn't they just include a duster on there? And it's like, okay, right. But everything that you include has an inherent risk with it. And so, like, it's easy to point in retrospect and be like, well, they should have had an antenna. But I also don't know the whole situation.
Right. And Michael and Jack, we can bring up
that's a good tease for a future topic in a few minutes here when we get to Starship. Non-folding grid fins. Have you seen that, Joe? That the grid fins are not going to fold? Can you? God.
We have questions about that in our Starship thing. Yes.
Okay. But sorry, what were you gonna? Go ahead.
Yeah, as I understand it, the attitude right now, and I don't have like insider info or anything like that, but like as I understand it, the attitude right now is like, we will get this full stack thing to launch as soon as possible, and we will there are corners that can be safely cut here because it's an uncrewed flight, right? No one's on it. And I think the much bigger concern than super aerodynamic efficiency or anything like that you would lose from having straight grid fins out all the way up. But I think the much bigger concern in my mind is you are flying an appreciable number of Raptor engines in close vicinity with each other, and also there is no Block 5 octaweb that is protecting them if one of them kills a few of the surrounding ones. So I think there are lots of other things that they want to figure out. I think they want to see how close their models are for aerodynamics and structural loading and natural frequency of the vehicle. There's all of these things that they need to figure out. And so being screw it, we're just going to creep the grid fins out because it's going to take too long for us. It's going to take an extra week for us to design and build this thing. And we want this off the ground yesterday.
Yep.
I think for this type of program, it's okay to make that call. But I also, again, I build model rockets, right? But I think that's an okay call.
Let's do the rest of the news. I'm sorry for that digression, but we're gonna have to come back to that. Put a pin in the grid fin discussion.
Yeah.
Because it hurts me physically. Chris, tell me about some more space news.
Well, yeah. So I was going to say, so this Nauka thing led directly into a triumphant moment for Boeing having to be delayed a few days, at the least. So I believe this is a photo from Julia, taken at the pad of Slick 41 of the Atlas V after it rolled out with Starliner for OF22. It was, of course, while she was at the pad that all of this was unfolding in orbit, and that the loudspeaker at 41 apparently announced the rollback of the Atlas V rocket, which is how everyone at the pad realized something was wrong. But Atlas V and Starliner have been delayed to no earlier than Tuesday, August 3rd at 1:20 and 10 seconds Eastern Daylight Time for their launch to the International Space Station. It will dock about a day later to the ISS and stay there for about 5 days before coming down and returning somewhere in the western part of the United States. The primary landing site would be Wismar, or the White Sands Missile Range in New Mexico near Alamogordo. with backup locations in Utah and Washington, and a few places in Idaho as well. So we're looking forward to that next week, but that's where we stand right now. Flight readiness review passed, so Starliner is ready to go once the ISS is cleared for its arrival. But speaking of yesterday, we also had a pretty important reveal yesterday. So we had been anticipating that Wednesday of next week would be the latest day that we could get this Government Accountability Office report as to whether or not the protests from Blue Origin and Dynetics would be sustained. And as we all expected, it was a flat out denial and rejection across the board on everything that the two companies claimed was wrong. And this is good for several different reasons. One, it allows NASA to formally continue with SpaceX with the HLS contract and the lunar variant of Starship to return astronauts to the moon. It almost certainly means that SpaceX will be the provider of the lunar vehicle. They can still choose another one if Congress does actually come through with those funding lines for it, as Blue Origin had sort of demanded, but that's already being watered down in Congress. So the odds of getting the full amount that we wanted, probably not going to happen. But really important because this work can now continue. And the months and months of work stoppage on the lunar landing program can finally be overcome and can finally continue. So I think that was really, really good, and interested in what you guys thought of that, because it wasn't necessarily a surprise, but it was good to see it from my view.
I'm just happy that work will continue, because if we're going to actually try and hit this 2024 goal, I mean, this is the way it's going to happen. It's undeniably with Starship and with no delay, no possible delay. But it would have been cool to see two providers, even if it had to come from a protest. But Congress didn't give NASA that money, so I don't know. Joe, do you have any thoughts?
Yeah, my thoughts are not that valuable here, but I will miss alpaca just because I like alpacas as an animal. So that's the Dynetics vehicle, right? It's called alpaca. And then I also yeah, I agree. I'm just glad that work is being done. I don't have a really hard line opinion on which one is the best, but the best solution is the one that's happening.
Yeah.
And
Mhm.
I would.
I know that things are happening at all of these companies, but just pick one. Just do it.
For sure. I mean,
And I.
no,
Okay,
go ahead.
I have a mildly spicy take.
Please, what's your spicy
for
take?
it.
Don't cancel me for this. I kind of just feel like if you are funded by the richest person on Earth, go to the moon, still go, go.
Yeah.
You can fund it.
100%. I would agree with that statement.
Mhm.
But imagine the roasting that he would get for going to the moon if, given all the roasting he got just for going suborbital. So.
I think, well, okay, not Jeffrey Bezos himself, born in 1964, but I think that I just think that they can probably still fund it and be okay to get a Pathfinder thing there or something like that, and that seems reasonable.
What is Michael highlighting here?
Well, so so Michael is highlighting the thing that came out 2 or 3 days prior to the GAO saying, yeah, no, there's nothing to protest here, which was this, I'm going to go with odd as the adjective, open letter from Jeff Bezos to Nelson, saying that all of a sudden Blue Origin would amend the contract to give NASA $2 billion over the first 2 fiscal years for free over their bid. So essentially, it changes the bid from $6 billion roughly down to $4 billion roughly for what the government would be on the hook for. And I gotta admit, that's something that as a taxpayer I should be really happy about. But like most things in Blue Origin's life, I look at and go, I don't even know if that's legal. And even if it is, it's sketchy. Very, very sketchy how you're doing this, because you're fundamentally saying, well, we didn't have to bid $6 billion to begin with. We could have bid 4. So now only give us 4. But there are questions of the legality of that. And of course, the GAO said no outright. So NASA is not forced to give Blue Origin a contract. But I don't know, kind of fishy that now when the writing was sort of on the wall, now you offer that. Like, well, why didn't you offer that a year ago when the contracts were being made?
Yeah, I mean that's sort of what
Where's that $2
SpaceX did,
billion?
right? They were like, hey, we're developing this anyways. We're gonna put X amount
Mhm.
into it. I forget what the exact figure was, but that was part of SpaceX's bid, right? Is they're saying, hey, we're
Right.
developing this anyways. We're putting our own resources into this. So if you want to piggyback along with a lunar variant, feel free. And Blue totally could have done the same thing and said, hey, we're building New Glenn. We're going to the moon. If you want to piggyback along, we'll put in $2 billion of our own work. That sounds great to me. Kind of coming in at the last moment with a Hail Mary. Hey, we'll give you $2 billion worth of work. Yeah, that struck me as kind of untoward. But hey, hopefully they still go. That'd be really cool to have multiple company. We don't want a monopoly on any
No.
access to space. So hopefully Blue Origin gets its act together, builds some engines, delivers them to Tori, builds New Glenn, and does all the things we want to see them do. Road to space. # road to space.
Well, since we're gonna do
Hold on.
#road to space, Michael, skip to Ariane 5.
Thank you.
Because I wish I had a video to show you of the Ariane 5 launching yesterday, but unfortunately, I have 2 photos to show you. One is prior to its liftoff when it was sitting on ELA 3, the Assemblée de Lancement 3, the launch pad that they use for it. And then the second photo is the liftoff, which I agree. What a liftoff! It was a gorgeous liftoff just right before sunset there in Kourou in French Guiana. Unfortunately, that's all we got to show for you because there was no actual video of the launch from Arianespace. But snarking aside to Arianespace, the mission was very important. A very important return to flight for Ariane 5, proving out the payload fairing separation system that had suffered some issues on the 2 previous missions. They never lost the payloads on the 2 previous flights, but the payload fairing definitely didn't come off the way they were anticipating, and this created a lot of concern for future missions, most notably the November scheduled launch of the James Webb Space Telescope on this rocket. So very important that this mission went well. It did. The payload fairing, by all accounts, separated nominally. And there's one more flight now of the Ariane coming up in late September before the all-important, and oh my God, I don't know how much we're not going to breathe during that ascent of the James Webb Telescope.
It'll probably be the most
I have
activity for a launch. Go ahead.
the big anxiety about that.
Yep. Yep.
Yeah.
Yeah, and then because imagine the backlash from armchair experts on Twitter if it doesn't go well. Everyone's like, "Why do we waste all this money on a telescope?" Just like,
If it doesn't
Anyway.
go well, I'm gonna scream.
yes,
Yeah.
we could just all get on that week's NSF Live and it'll just be an hour and a half of us all just screaming.
Yes.
So let's see. That was Ariane 5. Was there any other? Yes, there was other news. Rocket Lab returns to flight, right?
Yes, there was. This was the other one that I mean, man, this one took everyone by surprise. On Wednesday, Rocket Lab said, "Surprise, we're launching tomorrow at 2:00 in the morning Eastern time." An immense surprise to everyone. They usually give a lot more notice for this. It was a sort of classified-ish mission. I mean, it was going up to the Air Force Space Test Program. It was testing a new sensor. And things like that, but it wasn't like information was really out there about this. But the interesting thing about it was originally supposed to go from Wallops in Virginia, but apparently the automated flight termination system that Rocket Lab has developed for Electron has not received certification to fly from Wallops, and it needs to receive certification before those things can fly, especially the big NASA lunar capstone mission coming up later this year. So it was a little weird that Rocket Lab just chose to basically keep this a secret. That's not something Rocket Lab usually chooses to do with their launches. A bit disappointed in it, so we'll see how they continue. But it was a success, and it's a little chili up here, named after the New Mexican green chili. Jack, I know you're happy about that too, or appreciate them as well. But yeah, it was a good success, and nice to see Rocket Lab flying again, if not a little weird on the timing of their announcements.
Probably just a customer request, right? Like
I would
keep it hush
really
hush.
hope so. Yeah.
That seems plausible to me, anyways. But really good to see Rocket Lab return to flight there. Joe, speaking of automated flight termination systems, are there levels of model rocketry that you might have a flight termination system on the rocket, or is that just like don't put a bomb on a missile kind of thing?
Yeah. So, okay, I guess as a blanket statement, yeah, don't put a bomb on a missile. That's not hot girl energy. It doesn't spark joy. Don't do it. So, yeah, for FTS stuff and at the model scale, a lot of what at least I end up doing is not blowing up the vehicle, right? That's like a bridge too far. But it's like popping out the chutes early, or if you had active control over your motor, if you were doing something that was like a small liquid rocket, a lot of the FTS on things like that fly is just cut the thrust, close the valves, and so like there is no benefit to putting a line of det cord along the vehicle here to like increase your dispersion or anything like that. But yeah, so I do have FTS on most of my rockets. Not for Lumineer didn't have one. Lumineer had the ability for me to send a shoot deploy command wirelessly if I needed to, but yeah, the FTS on the smaller stuff I fly is just pop the chutes out.
Got it.
Yeah.
Cool. Well, I think with that we should move into Starship news, and look at this. Michael is pleased that he got a reply from Elon himself, and it's what is that? It's like a 3-minute old tweet. Elon
wow.
Elon talking about stage 0, which is everything needed to launch and catch the rocket, is at least as hard as the booster and ship. So this morning we saw the orbital launch table stacked, and that is, it looks like what he is replying to.
And he says catch again. So
yeah, he does say that.
When do the arm grabby things come, Elon? That's my question now.
Yeah, that's a fantastic question. Oh, looks like he also to your point, he just replied to somebody else and said, we'll post once we have a decent so someone asked him how the catch arms will work, and he said, we'll post once we have a decent simulation. Our first design will probably be far from the bullseye. So he's, as always, padding expectations there, but I mean, it does seem like they're building some of that catch hardware already. There's various, tubular structures at the launch site that have been being assembled. There's a yellow one and at least one black one, and just like we're just waiting to find out what those are going to end up being. But some kind of arm, or catch arm, or fuel arm, or who knows. But super cool. You got a reply there, Michael. Let's see what else happened this week. Did anything happen with Starship at all? Of course.
Of course.
Loads happened. Loads happened.
Not much.
Yesterday, we had GridFin install, which now we can get back to our GridFin discussion. You said, Joe, that so we were talking earlier about the GridFins not retracting. Like, there's no obvious hinge mechanism on this structure that we've seen them install the GridFin on, and I think we've all sort of independently heard rumblings that, like, hey, they're not going to retract. And I think Elon even replied to somebody and said, somebody said, like, no part is best part, which is an old Elon aphorism, and Elon said yes. So
yeah,
no
hinge.
hinge.
Why would you like splurge for some actuation and get aerodynamic efficiency? But I actually think it's like a fine call to make. This is the point. I don't want to like sound dismissive. I actually think it's like a fine call to make if you can power through the ascent up to 15-20 kilometers where like you're out of the atmosphere, you're out of crazy loading. If you can power through that, and it will cost you significantly less time to not actuate them in and out. I think they just really want to get it off the ground.
Could this have been part of the sudden increase? Because I think that the number of Raptors was stable for a long time at 29, and then it shot back to 31. Do you think that could have been part of it, like to help counter to help counter the inefficiency of that aerodynamic early ascent?
I don't know.
I think, and I'm not a rocket scientist, I think having them out is minimal. Their thinking, anyways, is having them out is minimal in terms of added drag compared to the added mass and complexity of hinges. It's a standard best part is no part type mentality. Like, what if we just never put a hinge on it? Then there's no hinge to possibly fail.
I
And
don't see it as a failure mode so much as it's added complexity in the system, and
mass.
we want path to flight. Yeah, right.
But so what if they never fold, Joe? How would you feel about that?
Garbage.
Like,
Nuh-uh.
like,
I
like
disagree.
like ever on any future booster. What if they just this is how it looks?
I think I think that's ridiculous. Like, I think you absolutely have a hit on performance for that. I don't know exactly what that hit is, but like,
We'll just add more engines.
just fold them in. It's not like it's not hard to fold them in. But I also know that it will cost them time and people power, or employee power, whatever you want to call it. It will cost them that to do it now. Like, I think if I doubt the real plan is to not fold them in.
I mean, I have to laugh because it just seems like at some point this is just like really taking the how Kerbal can it be? Like, the grid fins won't retract for aerodynamic. Well, how do we solve that? Just add more engines,
I mean, maybe the hit is not as appreciable as I think. Like, maybe it's not actually that bad, but it also, like, it's gonna look weird.
I mean,
for a
some
company
we know they know.
For a company that's notorious for being really good with their aesthetics, having a booster that's just constantly stubby fin. But it's important to mark that these are all prototypes, right? So it could change if it even is the case. We don't know. But Booster 5 could have ones that hinge out. Booster 6 could have them. It could be the same until Booster 20, and then they hinge. I mean, these are all very early prototypes still.
So I'm probably not the only one with this question, because I know we saw them, and I know then they got added yesterday. They started being added, but when we say hinge, we mean like hinge down for aerodynamics. But could they also just? Do we know if they can?
Yes,
they do that. So it's possible they could just rotate them for liftoff to be as aerodynamic as possible, and then redo them after stage step.
I hadn't thought of that. Joe, go.
Yeah, I thought the same thing too, Chris. And then I saw a take on Twitter from a guy, Patrick Morrison, who I was like, oh wait, which is as long as you don't have a crazy high angle of attack, like, it may actually still be better to keep them totally flat when you're going up. Like, you might actually have more surface area exposed to the airstream if you're sideways, because most of the grid fin is space. It's not the metal. So I don't know. I mean, maybe they would.
I guess
really it depends on which is worse.
I just really hope they fold eventually. I really hope they fold eventually. I'm just gonna keep saying, I'm gonna click my heels together with my red ruby slippers and say, I hope they fold eventually. I hope they fold eventually.
And I'm also wondering too, like, if there's some weird way that, like, as part of the design, if they're out like that, and maybe slight feathering of them during ascent, not rigidity, but slight tweaking, because the shuttles, Elevons did that during liftoff, where they would move to reduce the aerodynamic stress on the orbiter and actually push the aft attach struts into the tank as it went through max Q. So I'm wondering if there's some weird thing they figured out that it could actually benefit the ascent profile by having them like that to help with steering a bit. I don't know, throwing that out there.
Yeah, that would be. Go, please. Fill my brain.
It would be really negligible, but it does help shift the center of pressure back a little bit, which the further back your center of pressure is, the easier it is for you to keep the vehicle stable. And like a big issue with Starship, not issue necessarily, like, they have world-class GNC engineers, they know this, but like, there are huge fins at the top. And those fins are going to have crazy aero forces if you're not really pointed right into the airstream. And so it does kind of help to do what you can to shift the center of pressure back. The grid fins at the top of the booster are going to have almost no effect on that, but they might have a little bit. Maybe it turns out that that's important for them. I do hope they fold, though.
Oh, same. Yeah.
Let's see. So did anyone else have anything on the grid fins? I mean, they're massive. They look super cool. I can't wait to see more installed.
I want a new grid fin table. Have you guys seen the grid fin table that they have at SpaceX? There's a coffee table that's a piece of glass over a grid fin.
Yeah, like in the lobby area, right?
Yeah, yeah.
Ah, nice.
So cool. I do sort of wish they would sell pieces of Starship or pieces of a decommissioned Falcon 9. I'm all ITAR stuff aside, like I would totally have a Gridfin coffee table were I rich enough to have one.
Yeah.
So
I don't think
that
it would cost nothing.
There it is. Yes.
yeah, there it is right there. Beautiful. It's bigger than you, like than you would think that it is. I don't know how else to put that. The scale with rockets is always kind of tricky. But that other shot we were looking at is a live shot.
Look at that.
Shout out to Starbase Live. If you guys don't know, we've got the 24/7 Starbase live stream going. That is a shot of the orbital launch site. The tower is complete. We saw the 9th section stacked earlier this week, and furthermore, this morning, even stacked was the orbital launch table on the mount. That is starting to look like a proper launch site. What do you guys think about that?
That's what struck me the most is when Michael put that image on screen. I was like, oh my God, it looks like a launch pad now. Yeah, and that made me probably more ridiculously excited than I should have been. But yeah.
In a lot of ways,
man.
It's meaningful. I mean, it's like when they put the first nose cone on SN8 or whatever, and it suddenly went from being a tank that was just a hilarious looking stubby tank to actually, oh, this looks like a rocket. Like, I don't know, the addition of that of the 9th tower section with a little bit of overhang and the addition of the table to the mount, it's looking like a launch site.
Yeah, it gave me the same feelings that I had like when they were redoing 39A after the shuttle era and transitioning to SpaceX. It's the same feeling I have when the ML has been hauled out to be for the SLS rocket, right? Like it starts to look like a pad, right? It starts to look like the thing we're familiar with as programs, as that like, well, we need that in order to get to orbit. So yeah.
I have a question. I don't actually know. How close are those Gse tanks to the pad?
Fairly close.
I
guess
I'm not a good estimate of like distance or whatever, but yeah, there's some telephoto compression going on in this shot, so it looks they're not like next to each other, but if you were standing at the orbital tank farm, you could throw a rock and hit the orbital launch mount.
Oh, that close.
Yeah.
Okay.
It's
like
super
they're
close.
close enough that if Starship go boom,
Yeah, no,
we're
so that's the
rebuilding.
concern, right? But I guess the other thing is that like if Starship go boom, like it is big enough that honestly doesn't matter if we take a few tanks with it. Like if it's it might be one of those calls where it's like it just doesn't even. It's all going down if it goes.
Yeah. The crazy thing to me is that oh, it looks like we got some. No.
I love the graphics.
Not far.
Oh man, but yeah, it's
is that imperial or metric?
Both.
It's Baylor. Let's see. But
well, no, Joe. Since you're changing all your names, it would be Beartrick or something like that. Betrick.
Oh, okay, never mind.
So yeah, it's super close, and the thing that strikes me isn't quite so much how close they are, although that is striking. It's also no flame diverter. Remember the whole no flame diverter thing, which we have a question about. Let's see if I can find it. Bum bum bum. What is your opinion about no diverter? I can't help but think they're going to build some more berms or what have you at the launch site and try and make it so that there's not a direct path from ejecta or whatever you want to call it, debris from the launch mount to the orbital tank farm, but we haven't seen too much evidence of that yet. But maybe the answer there is more dirt berms, because they sure have been fond of building those lately.
More dirt.
But yeah, I mean, do you think there's so many things that we don't know if it's going to end up being that way into the future? Like, will no flame diverter work out? I doubt it. Will the catch arms work? I sure hope. What is the booster gonna? Is the booster ever gonna fold its grid fins? Like we just don't know. But that's kind of the fun of watching this.
I love
day
the full
progress,
send
right?
flag. I think that's great.
Yeah, that was a super nice catch on Mary's part there. I mean, so cool. I mean, that is definitely the esprit de corps, right? If that's even the right phrase to use. I think that is the mindset of everybody on site right now, is just absolutely send it.
And man, they're going. I mean, they they appear to be going all out. I mean, yeah, the rate that they're stacking these together now is kind of impressive. I mean, we know they had kind of wanted to have a stack out there by the end of July. We're obviously at the end of July today, so
They have a few hours to get that done. Yeah.
a few hours. Yes.
Yeah.
So buckle up for the stream extravaganza. No. But no, I mean it's good in some ways, but like it's also interesting to see the things that they choose to go really fast on and things that they appear to rush. Like getting it out there to me is like, that's great. But once it's out there, what do you do if you don't have fuel to fuel it yet? You know, if you can't.
You take cool photos, duh.
Well, right. Like it's a PR. It's a get this out there and let everyone see it. And I kind of hate to say it, but who even knows if Ship 4 and Booster 20 will be the ones that actually fly? I mean, maybe it's 5 and 21 that end up doing the orbital flight. We just don't know because of how quickly things change. So it'll be fascinating to see what they learn from the stacking of 4 and 20 together, and see what they can make of it when it's out there on the pad.
Yeah, I mean, PR stunt aspect aside, I do think
Ship 4 and 20.
It's got to be. It's got to be.
Considering they skipped 16, 17, and 18 and renamed Booster 2 to 3.
What if we just go straight to 20? Then it would be 4 and 20.
Yeah.
Oh, man. I mean, you're probably not wrong, Joe. It's got to be intentional. Let's see. What was I going? Dang it.
It's at least conscious. Yeah.
There goes my train of thought completely. Oh, yeah. There's meaningful data to be gathered from stacking the ship on the booster. It's like a fit check, right? Versus even if not everything's ready, maybe you discover something that you need to change for when everything is ready. And so there's it's absolutely useful to do that. Even though, yeah, I totally expect them to stack a ship on a booster before everything is ready, even FAA, whatever, launch site infrastructure aside. Just because it's going to be cool pictures, and I, for one, am excited for those cool pictures. Because it's going to get people excited.
Yes, exactly.
You want to play some? You want to play some bets on when the actual first, like when the orbital attempt lifts off? You want to play some bets?
Okay, I will bet you $1.
Nothing. I mean, just
okay, nothing.
I bet you nothing. That what are your when do we think this thing is actually gonna lift off the pad?
December.
I'll go November.
You just $1'd me. Don't $1 me.
Michael says 2022.
Okay.
So Michael thinks SLS will launch first. That's Michael's guess.
I think November.
Okay.
Well, that doesn't necessarily mean SLS will launch first, but yeah. Sorry, no shade. But yeah.
I love the silent commentary from Michael on screen. It's like, oh god. Sorry, go ahead.
I think November is I mean, it's not going to be August. It's not going to be September. It's not going to be October.
I think earliest plausible, all environmental stuff aside, if everything goes right, to me, earliest plausible would be like October timeframe. Like they need to get the orbital tank farm finished. It seems like if the tanks that they have rolled out are finally good and they can actually start putting the shells on top of them, they should be relatively close to like a minimum viable functionality for that orbital tank farm. But there's still some time away. But yeah, I mean, I can see November. I can see December. I can see 2022. I obviously want it to happen as soon as possible in a safe manner, but yeah, it's just time. Sometimes things take time, and that stinks. Stupid human timescales. Let's see.
But the fact that we all sort of agree that it's plausible by the end of the year is like astounding, given the rate that this is going. Because even though they are encountering delays and schedule slips, like they're not on the same magnitude that other programs have been, if that makes sense. You know, like there are still delays, but it's not as much as we've seen with others.
Absolutely. Let's see. I'm going to look for some user questions here, or viewer questions. I don't know why I always say user. If you guys have any questions at NASASpaceflight, we could answer your Starship questions here. I also realized we have a bunch of good questions for Joe that I didn't ask because I was too busy fan-guying out about your intro and stuff. But I really want to ask
Yeah,
some of
ask
these
away.
now.
Ask them.
Hopefully chat doesn't just completely rebel. Okay, we're gonna do some Starship questions, and then maybe I'll ask Joe some questions before we completely wrap up here. Bum bum bum. Okay, Nathan is asking, do you think the grid fins will raise or lower the center of pressure considering Starship's flaps? You were saying it was going to lower the center of pressure, right?
If you're looking at the whole stack vertically, it will lower it because you have more drag towards the aft. And but like, it's it's more drag towards the aft, but like the grid fins are what 30 meters maximum from those. I don't know what's the Starship like full stack height. Do you know?
This full stack height is 118 meters.
Yeah, so you're like I don't know, you can't be more than 10 meters. Like, and they're not an appreciable amount of area compared with the flaps. Like the flaps are pretty thick. They have a big cross section, and it would shift it back. It would not do it by much, which is why I'm like, I don't think there's a lot of weight to the theory. Like, I think it's possible, but I don't think it would be appreciable.
Mm-hmm. Got it. Let's see. T-Cool asking, can't they use the old tank farm? Don't think they need a full fuel load for the first stack. I don't think that original suborbital fuel farm can do much more than fill a Starship. Maybe I don't even. I guess I've never looked at the size of the tanks.
Yeah.
Can that orbital tank? Okay, so even if they use the suborbital tank farm, they would still need more space for the booster.
And correct me if I'm wrong, things change a lot, but I don't believe I've seen any cross-country fuel lines going from the suborbital farm to the orbital launch site.
Nope, not unless it's something that got buried and RGV caught it and we didn't see it because it was in the back behind something. I don't recall seeing any lines buried like that across the launch site.
Which would indicate that they literally can't, because there's no way to get the propellant from those tanks at the suborbital farm into Starship on the orbital.
Buckets.
Well, that's true. I mean, yeah, as they go across, yeah.
But a good question for sure. Let's see. Okay, here's a question for Joe. I'm all over the place. I don't care. Fight me. Andy is asking Joe, what is the largest amateur rocket size allowed?
Well, the line between amateur and professional is not well defined. You can call it like you see it. So like USC did a space shot, University of Southern California, they did a space shot. They've done multiple. And if you want to consider it amateur, you could, because they're not, it's not a commercial endeavor, I suppose. But that is an R motor. That is, I think, hundreds of pounds of propellant. They are pouring their own motors. Their propellant is ITAR classified. Like, it is a real rocket. But you could consider it an amateur effort, I suppose. I think the line is not well defined. At some point, you just start filing FAA waivers. Like, we had a waiver for BPS.space for the Lumineer launch because it was a private launch site. You put up a waiver. You tell them, here's what's flying. So like, it depends where you want to draw the line between professional and amateur.
Got it. Looks like Michael has put up another Elon tweet about the grid fins. What is this? Let's see. This is just me reading Twitter on air. Let's see. Grid fins, blah, blah, blah. Something with much more drag to reduce terminal velocity and so reduce landing propellant might have better performance. Not sure. Potential future optimization.
What if you had like 4 big grid fins, but they're attached to strings at the top of the booster, and they sort of trail behind, and instead of a grid fin shape, it was more of a circle.
Yes. Maybe they were made out of cloth instead of metal.
And then what if you had even smaller grid fins with a similar shape though that went out first, so that it helped pull out the larger? Could be, I'm kidding. It's a dumb joke, but yeah. I have no idea.
Good stuff. Let's see. Looks like Elon is talkative on Twitter today, though. That's good. Hopefully, we'll get some more interesting information out of him. Let's see. Another Starship question. How about? Oh, actually, here's one for Joe. Do you plan on doing liquid fuels at some point?
Yeah. I keep talking to different people that I would want to work with. I can't do it on my own because I don't have the experience to feel comfortable with it. Like I don't have the like fluids engineering or chemical engineering background that I would want to attempt something like that. But I would be happy to do it working with other people or like I love the idea. You guys know Maston Space Systems. They do that. They
They're
just
the
did a
best.
recent flight, but they have like a hopper vehicle that moves around, tests GNC algorithms. I
Yep.
would love to do something like that for liquids because that's where you really get to show off the benefit of being able to throttle and hover and translate. And so I have a vehicle that uses a fan that does that. But yeah, there it is on the screen. Doing something that is, I don't know, let's say half the scale or a quarter the scale of that, whatever you can do smallest with a little bipropellant LOX ethanol engine would be really cool. But
Yeah.
I would need some help.
I mean, hey, you're in Southern California now. Maston is just right over there in Mojave.
Yep.
Make some friends. Let's see. That Elon tweet threw me all out of whack here. Let's see. Maybe a couple more questions. Joe, I know we are over our time now. I want to respect your
I don't
time.
know.
And, okay, let's see.
Man, I build model rockets as a job. Like we're good.
Here's one that I know the answer to, but I'm going to put up because it interests me because I'm selfish like that and I control the buttons and levers. What about launching a rocket from an RC plane as Virgin Galactic did? Would be cool. Is that something you thought of? Is it doing an airdrop?
We have I don't know where it is. I have the Launcher One vehicle designed. Like I have a model designed. It's 1/66 scale or it's 1/20th. I don't remember exactly what it is, but I have that. I have the carrier plane. I've done a couple of like captive carry flights where we were like upping the payload on the carrier plane, and that the last time any of that happened was in December. But I do have like designs for one of those. It just turns out to be that like I'm not that good at planes, so I'm working with a couple other people, and it's a very slow moving project, but I do have some plans to do that.
Super cool.
Oh yeah, that plane's long gone. That thing went right into the trees.
As they want to do. It's
Yeah.
like the trees just call them like sirens on a rock.
Big hungry. Actually, this is the footage if you want to see it. And I ended up finding it, but it took like 6 hours of walking through the woods to find this thing.
Ooh,
It's a really interesting failure.
that does not look like a fun time.
Oof,
It
no.
wasn't incredibly enjoyable. No.
How much of your life so far would you say you've cumulatively been like wandered the wastes looking for debris of something?
Oh, not that much. That number is going to go up a lot. If you start flying higher things that aren't, trying to guide back to the pad, like stuff goes everywhere, and the wind has a lot of effect on that. And if you can't communicate, or if you don't have a signal broadcasting from whatever lands, it's a lot of work to find it. Like we covered for searching for Lumineer, because the vehicle went silent and because we didn't know exactly where it was, and the last ping was from like 3 kilometers up. We spent, I think, 4 or 5 hours looking through the desert, and just like, I think it was 5 or 6 people total. We spread out like 200 or 300 feet apart, and then you're just walking, doing this for hours. It's an experience.
I bet. I mean, I've went out looking for meteorites. I've still never found one, but it's kind of the same thing, right? You spread out from the people that you're with, and you're kind of just looking and looking and looking, and but not something, didn't put a whole bunch of time and work and money and energy and love into a meteorite. But
Yeah.
still, I get it. Let's see here. I think that is about it. Some people saying that there was a connection between the 2 tank farms that RGV caught. I didn't catch that. That must have just missed it.
Yeah, I didn't catch it myself. Yeah.
Let's see. RGV always good with those views. Bum bum bum. I think that's about it for this week. Definitely want to say thank you to Joe for joining us. Joe, thank you for joining us.
Thanks, Jack. Thanks, Chris. Thanks, Michael, and all of the people from NSF. This was fun.
Yeah,
it was awesome talking to you about your work, everything, man.
Definitely
I'm down to
would
do
like
it whenever, so just let me know. Yeah.
You beat me to the punch. I was going to say I definitely would like to have you on again. It's been a joy talking with you. And guys, what is it? BPS.space.com?
It is BPS.space. Got that Squarespace domain?
Hey.
Not sponsored, but like you can take advantage of the free .space domain and be like, well, it's at space. It's BPS.space. Really, the more interesting stuff is I think either at Twitter at Joe Barnard, on Twitter at Joe Barnard, or on the YouTube channel, which someone can link in the chat. If you look up BPS.space, you'll find it.
Yeah, definitely go check out Joe's YouTube channel. It's an absolute joy to watch, as I previously gushed for 30 minutes. But seriously, thank you so much for joining us, Joe. And I mean, if you guys, it's like How It's Made, but for rockets. How could you not like that? Just go watch his videos, please. Chris Gebhardt, thank you for being on the show today. Assistant Managing Editor of NASA Spaceflight.
My pleasure as always.
I think you might get fired by Chris B because it took us like an hour and 20 minutes to mention shuttle. But Chris B was also in the chat saying Buran was better, which it's not. Everyone go look at the farewell dossier. I'm not going to get off this soapbox. CIA.gov farewell dossier. Anyways, I'm Jack Beyer. I'm the guy with the beard, with the Land Rover. Speaking of, we're now basically neighbors, Joe. If you need someone to drive around the desert and find things, or if you ever just needed a ride, or you want to hang out and have some cupcakes, just hit me up. California, best coast, best state. Don't fight me. Anyways, I'm Jack Beyer.
I won't fight you.
No, I said you can't, and I have the power to close this out. So here I go. Ha ha. Seriously, thanks everybody for watching. Thank you to all of our members. So many members. I still think we need to have someone read all this out and then compress it into like a 1 millisecond long high frequency data burst, kind of just like, thank you. Your name was said on stream. Thank you so much. But really, there's no possible way that we could read all of these and in any appreciable amount of time. And so that's a good thing. That's a good problem to have. So thank you so much to all of our members for supporting what we do, because, I mean, just look at Starbase Live today. We were able to spool up and get that launch table lift. Is that a photo from Mary? Look at that.
I think that was I don't know who that was. I thought that was an Elon. Yeah, moving at warp 9. There we go. See, he is working on warp drive. I knew it.
Oh man. Oh yeah. Okay. I just got the notification on my iPad. Thanks, Steve Jobs. I'm 1 millisecond behind. Anyways, I digress. That's the orbital launch table going in. Looks like Elon is down there in Starbase. Goes to Steve Jobs haunting me as usual. Everybody, thank you for watching. I think that'll do it this week for NASA Spaceflight Live. Go sub to Joe's channel if you haven't already. Go, Joe, do it. Go do it. Why are you still watching this? Go do it. Or like or yeah, just go.
Which are none,
Anyways.
but yeah, go do it.
Yeah. All right. Thank you everybody for watching. We will see you next week.
Propulsion continues to be normal.
Our chamber pressure looks good. Traveling up.
Roger, roll, Atlantis.
Water towers, fly! Yes!
Echo Delta nominal.
Flight down, feed off. Bring in, feed off.
Yikes. You bet. Concur. We don't need any more of these.